the problem. A 0.5 kilogram ball is thrown against the wall at an angle of 53 degrees as shown on the right. Here is the ball thrown at an angle of 53 degrees. That is the angle 53 degrees. And the velocity, initial velocity, is 10 meters per second. It rebounds with the same speed, means 10 meters per second, at an angle of 53 degrees. Now, it rebounds at 53 degrees as shown in the diagram. This is the velocity of impact, and this is the velocity of rebound. Alright, this time also we need to find the change in momentum of the ball. The difference between this problem and the previous one. In the previous one, the momentum was just in one direction. It's a one-dimensional phenomenon. Whereas now, the momentum is a two-dimensional phenomenon. You can see the momentum is a vector quantity. It has an x component and a y component. So we need to now look at the component form. Okay, let's do that. Now, if this angle is 53 degrees, then this angle will be 127 degrees. Is that right? Okay. PI drawn from the origin. Now, this problem can be made simpler by drawing both vectors. What are the two vectors? The initial momentum vector and the final momentum vector. Now, if you can draw both vectors from the origin. Now, in order to do that, what all you need to do is translate this vector so that its tail is now on the origin. Now, I'm going to draw that over here. So, where will this vector be drawn? It will now be this vector. You see that? As long as the length and the direction remains the same, these vectors are the same. It is simply translated. So this is the initial vector PI that makes an angle 53 degrees with the positive x-axis. That means the PI is the momentum magnitude and 53 degrees is the direction. And the final momentum you can draw at the same position. So this is the final momentum PF, and what is the angle of the final momentum? The angle of the final momentum is this angle, which is 127 degrees. So you must be very clear there. The initial momentum of magnitude PI, which we will be calculating shortly, makes an angle 53 degrees with the positive x-axis. The final momentum PF makes an angle 127 degrees with the positive x-axis. Alright, let's calculate PI, the magnitude of the initial momentum. Remember, momentum is mass multiplied by velocity. The mass of the ball is 0.5 kilogram. Its initial velocity is 10 meters per second. So PI, the initial momentum, is 0.5 kilogram times 10 meters per second. That is 5 kilogram meter per second at 53 degrees. Alright, let's write that in the component form. Can you help me do that? PI is 5 kilogram meter per second at 53 degrees. What are the x and y components of PI? PI in the component form is 5 cos 53 degrees I plus 5 sine 53 degrees J. I'm sure this is now familiar to you. Is that right? There is no problem there. 5 cos 53 degrees I, that is the x component. 5 sine 53 degrees J, that is the y component. And now use your calculator to find the value. 5 cos 53 is 3 and 5 sine 53 is 4. So Pi is 3i plus 4j. Now how will I represent that over here? This is 3i and this is 4j. The momentum Pi has the x component 3i and the y component 4j. Similarly, let's write the final momentum in the component form. Pf is 5 kilogram meter per second at 127 degrees. In the component form, it will be, alright, can you write that? It will be 5 cos 127 degrees I plus 5 sine 127 degrees j. And using the values of cos 127 and sine 127, you get it as negative 3i plus 4j. The x component of this is negative 3i and the y component is 4j. And now, we have now broken these vectors into their x component and y component. Therefore, we can now find the change in momentum along the x direction and the change in momentum along the y direction. Alright, let's see how many of you have been following my argument. Tell me, what is the change in momentum in the y direction? What is the change in momentum in the y direction? Well, there is no change. Initial y momentum is 4j. The final y momentum also is 4j. There is no change. The change is the final value minus the initial value. You notice that the initial and final momentum along the y direction are the same. Therefore, there is no change in momentum along the y direction. But the initial momentum in the x direction is 3i. The final momentum in the x direction is negative 3i. And therefore, there is a change in momentum in the x direction. So delta P is Pf minus Pi, final momentum minus the initial momentum. And we will do that for the x and y separately. What is the change in the x momentum? It will be negative 3 minus 3. Negative 3 minus 3i, that is the change in the x momentum. Plus, what is the change in the y momentum? 4 minus 4j. And that is negative 6i plus 0j. In other words, the change in momentum of the ball is negative 6 units in the negative x direction. A very important type of problem. Alright, let's do another one. A loaded dump truck with a total mass of 5 times 10 to the power of 3 kilogram traveling at 3 kilometers per hour coasts into a loading dock and collides, coming to a stop in 0.64 seconds. What is the magnitude of the average force exerted on the truck by the dock? Well, the truck comes and hits the dock in coming to a stop. So it is the force exerted by the dock that stops the truck. Well, what is the principle we are going to use here? The truck, before hitting the dock, has an initial momentum. After hitting the dock, it comes to a stop in 0.64 seconds. So its final momentum is 0. And that will help us to find the change in momentum. The change in momentum occurred during this time. We can calculate the rate of change of momentum. And what is the definition of force? We just had in the beginning of the class. Force is a measure of the rate of change of momentum. Alright, let's do that. Here we got, this is the dog and this is the truck hitting and coming to a stop. The mass of the truck is 5 times 10 to the power of 3 kilogram. Its initial velocity VI is 3 kilometer per hour. Convert that to meter per second. Divide by 3.6. That is 0.83 meter per second. What is this initial momentum? Initial momentum PI is mass times initial velocity. Mass times initial velocity, and that is 4,150 kilogram meter per second. What is the final momentum after it comes to a stop? Its final momentum is 0. What is the change in momentum? Change in momentum is final momentum minus the initial momentum. So delta P is PF minus PI. That will be 0 minus 4,150. That is negative 4,150 kilogram meter per second. Now look at this. The change in momentum is opposite to the direction of motion of the truck. Why? Because the change in momentum is caused by the force applied by the dog on the truck, which is directed in the opposite direction. That is why the change in momentum is negative. And this change in momentum occurred during a time of 0.64 seconds. Therefore, force is a measure of the rate of change of momentum. F equal to delta P divided by delta T. We have delta P is negative 4,150. Delta T is 0.64 seconds. Therefore, the force equal to negative 6.5 times 10 to the 3 Newton. This is a measure of the force applied by the dog on the truck. Watch that, it is negative. Why is it negative? Because the motion of the truck, we considered the motion of the truck to be positive. If the initial velocity of the truck is positive, therefore the force applied by the dog on the truck is opposite to that, which therefore is negative. So the negative sign simply indicates that the change in momentum is opposite to the initial momentum. Okay. Let's